So as we said, yesterday we looked at like when the coefficient is 1. Today you'll start noticing that the coefficient is not 1 and there's no way to simplify this any further, right? So we're stuck using this process. Now if I can factor something out, I'd prefer to use the simple trinomial process than the complex one, right? So you can see how like in the first one I can't take that factor of 2 out, right? Because I can't divide 27 by 2 evenly. So I'm stuck, right? So with this, complex trinomial factoring is where the trinomial is in the same form, ax squared plus bx plus c, but this time the number out front of x squared is going to be greater than 1. Okay? It should be in the 2p. We don't touch this at all in the applied, the 2p, so that might be new for some of you. The 3u, you 100% would use it, and the 2d, you 100% use it too. Right? So it might be review for. It's a great review because I see kids all the time. Like in the 3u, you guys will do graphs with like that look like this, and like if you got that far, they're called rational expressions. It's 100% factoring, and kids cannot do it. Purely based on their ability to factor. So it's a great review to just go over this, right? So we're not going to do this in this course, but you see it, even the kids in the 3U struggle with the factoring thing, right? So we're going to take our time with this because this isn't an easy concept, and we're doing 3 different kinds here, okay? So it might take us 2 days. We'll just take our time and plug away with it, right? So we might get to the end of, we'll get to maybe the end of here. We'll take a break. We'll try the questions that go with it. And then if we still have time, we'll keep going. If not, it's okay. Right? So we'll just do maybe the first 2 pages. Then we'll take a break. Okay? We'll break it into 2 lessons. So, as we said, that's not 1 anymore. Right? So you can see this is not like our normal process. So when we come down here, notice that there are no, so I'm just right here. Notice there are no common factors, nor can we apply the simple trinomial method. That's what I was just saying, right? So we need to use a method called, it's what called decomposition is typically used, okay? So that might be a new word for you, maybe. But if you had to like think literally what the word decomposition means, what would you say that is? Breaking something down. Whatever that something is, we're breaking something down. That's the word decomposition. So that's a method that typically gets taught. And I'll show you that method, and then I'll show you an alternative that might make more sense. I think the alternative, when I saw the alternative, I thought it was a way better way, but I still have to show you the decomposition way. Right? Which is a combination of the sum product method, factoring, big grouping. Okay, so we need to determine 2 numbers, so we're just looking at this question now. Okay? So yesterday I said, when we fill out man, regardless if it's a simple trinomial or not, you're always looking at what a times c is equal to. That's what you need to check your multiple is, right? So if I were to write, here's a, there's b, and there's c, right? So even if it's an x, like a 1 in front of the x squared, you're always checking a times c to be what the multiple is, right? The nice thing with the simple trinomials is just 1 times the c value. That's what makes it simple. This one is no longer simple in the sense that this value is not 1 anymore, right? So we need to figure out 2 numbers that multiply to 2 times 36 in this question, right? So to 72, and add to negative 27. Okay, does everybody see where I got 72 from? This comes from when I multiply 2 times 36. Okay? And that's right here. The 2 that's out front, the a value, and the 36 that's the c value. Okay? When I multiply them together, then I gotta check. Now I just start checking. It's the same. After you do that, it's the same process as yesterday a little bit, almost. to come up with the numbers, right? So you need to figure out the two numbers that multiply to 72, right? So let's, again, a little bit trickier because the number's bigger this time. That's what makes this complicated, or a complex trinomial. We got to check, okay, 1 and 72. That's never going to add to 27. Let's go to the next one. 2. 2 times what gives me 72? 36. Still not going to equal 27. So keep going. 3. Right? This is where you might need your calculator to check these, because I don't know how many times 3 goes into 72 off the top of my head, right? Turns out that it's 24, right? So that looks nice. Right? That looks, as soon as I hit that number, I'm like, okay, if I added those two things together, I could get 27. But the problem is I need the 27 to be negative. But it still needs to be a positive for the multiple. Yeah, Ian. So if I both make them negative, when I multiply them together, negative 3 times negative 24 is going to equal 72. But if I add them, that's going to equal negative 27. And that satisfies both our conditions. Right, so those are my two numbers. Right? So we could, I got a little ahead of myself. So we could fill this in here. Negative 27. You could say the two numbers are negative 3 and negative 24. It's the exact same process as yesterday to come up with those two numbers. That's why I showed you the A times C thing. So you always think of this. It's always this. That way you just never like mistake a complex trinomial process for a simple one. You're always taking the A value, multiplying by C. Right? Okay. So use these numbers and decompose. And what did we say decompose meant? Break something down, right? So I'm going to say break down is what I'll say. Okay, break down the middle term of the trinomial. This is what we're going to like, this is the decomposition method, right? This is the first one I'm going to do. So you could pick either of these two methods, whichever. So if some of you are coming from the 3U and you've used decomposition, and that, like, you can just do decomposition and it's fine, right? For other people, particularly like if I had you in the 2P, or if you've had anybody in the school in 2P, they typically like using this table method, right? You use tables, the table for the expansion, it's the exact same table, okay? So I'll show you how that works. I think the table's really, really nice, okay? Decomposition can get a little bit messy, and it kind of like, people get confused with some stuff, right? So I'm all about like, ultimately we're going to use these processes to answer questions. The same thing as completing the square, right? So I want you to get to the stage or be able to complete the process so that you can answer the questions that I actually care about. I don't want to get you snagged on trivial processes. I want to give you the most efficient way that works for you, right? So I'll show you 2 or 3 different ways for each of them. You pick which one that works, right? To ultimately answer the questions that we're going to answer at the end. Because we're going to have word problems at the end of this. Same we had word problems at the beginning with the optimization. Just answering different things. So I'll do the decomposition first, right? So I chose this question specifically because we already know what the two numbers are, right? We just did that. So again, I'll write it down here. So we got to multiply to 72 and add to negative 27, which we found out the two numbers are, that satisfy those, are negative 3 and negative 27. Okay, this isn't like yesterday where we have to go like this now. Don't do this. Okay, if you see a number other than 1 here, do not do this. That will not expand to give you this, right? Negative 3 times negative 27 is not positive 36. You're not going to get the right answer if you do that. It only works if you have a number out front that's 1, right? What I showed you yesterday, Okay, so now we're stuck. Now we're stuck using this decomposition method. Okay, and what did I say decomposition meant? Break apart. What are we going to break up? Welcome. Hector, here you go, buddy. Where's this sheet? I got a mess here. Let's have a look. Okay, so I'm just going to rewrite this here so everybody can see what I'm going to do. Okay, so 2x minus 27x plus 36. Okay, I just rewrote the question. Now, decomposition is telling me to break apart the middle term. Okay, so that just means, okay, I'm going to do, I'm going to leave everything else in their spots. I'm going to write the plus 36 down here. And I'm going to break the middle term up. What am I going to break it up with? These two guys. But I'm going to selectively choose what goes where. Okay, that's the problem with this decomposition method. Sheets are all messy. Okay, 2x, I'm going to go like this, minus 3x minus, you guys didn't say anything. Why didn't you say something? What's that multiple supposed to be? So I'm doing the decomposition method, so I'm on the, you might be on the next page, Hector. Keep going. Or unless it's at the bottom of that. Is that at the very bottom? That's where I'm at. Okay, so with complex trinomials, instead of throwing the variable on the left, like what we were doing yesterday, I put it on the right. Okay, for complex. Okay. Now, here's where things get messy. And it gets messy, and this is why I'm going to show you the table method after, because you don't have to worry about this. Okay. So basically, what happens is you take this. You break it down the middle, and you kind of have two pieces now. It's broken down the middle, right? And you're going to look at, okay, well, what do I have in common amongst the first two terms, and what do I have in common amongst the second two terms? Like, what common factor can I take out of each of them separately, right, as halves? So in the first one, I don't really see a relationship between the 2 and the 3, right? So then I would just go, okay, well, I see there's an x there, right? So I could take the x out. And then I'd write what's left after I took the x out. So I'd write, okay, well, it's x minus 2x minus 3. Did we see that? So if I were to put that back in there, I'd get this line back, right? That's how I know I'm okay. So I'm always checking. Every time I factor something, I'm checking with the line above. I just get in the habit of that. I'm like, okay, did I do this right? Did I do this right? So when you start moving down the page, you're always looking back at the step before to make sure that you can get the step before back, right? Then I ask myself, okay, well, what's common in the second one? What's the biggest thing that could go into 24 and 36? What is it? 12. Okay. So let's go. I'll take, here's the problem though. I got to take out a negative. I could take out negative 12, right? What's left after I do that? Okay, so I'm gonna take negative 24 and divide it by negative 12. So it actually becomes positive 2x, right? Because if I look at this, if I wanted to get the original back, I'd have to, negative 12 times 2 would be negative 24, so then I'm okay, right? Now what's 36 divided by negative 12? negative 3. Now, do we see anything interesting going on here? What's the same? Stuff in the brackets is the same, right? So imagine, it has to be the same. These two things, in order to do this process right, and this is kind of what's a pain, it's a pain, but not a pain if you know that it has to be like that. Those have to be the same. Now, yesterday we did a question, didn't we, where we factored out a w minus 1 out of all 3 terms, right? That's the same thing here. So what I'm going to do is, to finish this question almost, pretty much, is I see 2 pieces here. I've broken this down, right? I see this piece is the first piece over here on the left, and then I see the second piece over here on the right. And in both pieces, I have something that's in common. So I can take it out, factor it out. So I'm going to write, okay, 2x minus 3. And what's left after I factor that at 2x minus 3 out? The x and the minus 12. So then I'd write that. That is your final answer. Not my preferred choice anymore. This is the way I got taught in grade 10, grade 11. Not my preferred choice. You can see how you make a mistake pretty easily with that. Yeah, well, no, because you're taking, so that you got, if I gave you something like this, I'm just going to write here for a sec, okay? And I'll erase this in a sec. If I gave you, oh, how am I going to do this? Okay, so this is me pretending that I'm trying to make a symmetry between what you've got up here. Okay, so again, I'm going to break this question down in the middle. Okay. So break it in the middle like I did the other one, and then I'm asking myself, okay, well, what's common? What's in both these pieces that I could take out? Is my question. 2. So I'm just going to take the 2 out, right? And then I'm going to write what's left after I have that, right? So this is like the same thing. It's a 2 out front because that's what I took out, and then I write what's left. X plus 1, right? Same thing up here. It's just this time it's not a number, right? It's just an expression. So I have it in both pieces. I'm going to take it out of both. Write it out front, and then I'm going to go, okay, well, what's left after I take it out? X minus 12. Right? That's how that comes out to be. Okay. Not my favorite method. You'll see in a sec when I show you the other way. You're like, I bet you all you choose this. When I tutor kids like this, when I was tutoring, it was just like, it takes half the time, half the effort, half the amount of thinking. Right? Okay. So, I'm going to do the exact same question. I'm going to show you how to do the exact same question with the table method. Okay. This is the exact same table that you used with expanding. Okay. I got to get to the table first. It's again, you got to, the precursor to get to the table, step 1, is to do the man method. Okay. So again, it's the same question, so we know what the multiples are and we know what they have to add to, right? They have to multiply to 72. They have to add to negative 27. So I know what this is going to be, right? Because we just talked about this. Is negative 3 and negative. It's always the A value multiplied by the C value. Okay. Always. Cool. Regardless if this is like, so Hector, if this was x squared minus 27, x plus 36, it's still the A value.
So it would be 1 times 36.
1 times 36.
Okay, cool.
That's what makes this a simple trinomial.
Yeah.
Okay.
Makes sense.
Good. Okay. Okay. So, same two numbers. Okay. Here's how this works. I love this method. This is my favorite thing. When I saw this the first time, I went, way too easy. So I want you to keep in mind how stupid that other process looked. Okay. Okay, so there's your table same table. Okay. How did we fill in the table? The inside of the table was the area, right? So area was equal to length times width. Okay. So the area is going to be the inside of the table, right? And then I have the length is along the top or the side, whatever, it doesn't matter, and the width is going to be along the side. So with the expansion, what did we do with the expansion? We were provided with the length and width, and we multiplied them together to produce the inside. This time, I'm provided, oh sorry, let me rewrite this. So this time I'm provided with the inside, right? The red area. And I have to figure out the length and width, okay, of the rectangle, right? So what I'm going to do is fill out the inside of the table. So always, here's how this works. So you're always going to put, this one and this one here and here in the table, top left, bottom right. Okay, ideally in that order. So the 2x squared is going to go here, and the 36 is going to go down here. Okay, and then the other two don't matter, right? I would put you could put the negative 3x here, and you could put the negative 24x here. Now here's why I love this. This is like brilliant. So here's what you're going to do. You're going to go, okay, I'm going to read vertically. Okay, so I'm going to look at the two factors vertically, and I'm going to pull out what's common amongst the two of them. Right? So looking like this, I'm going, okay, I got 2x squared and negative 24x. So I already know I can take an x out for sure, 100%. And then I'm like, okay, well, what about the numbers? Well, 2 goes into 24, right? So why don't I take 2 out? Because that's the biggest thing that I could take out numerically. And I can also take out the variable x, right? Then I go over to the other one, and I'm reading vertically. And I go, okay, well, what can I take out of there? Well, there's no x in the bottom, right? So I can't take the variable out this time. But negative 3 does go into 36. But the problem is this time, like, the negative's not in both of them, right? So I can't take the negative out. So I'm just going to take the 3 goes into 36 how many times? This is problematic. Why is this doing this? Yeah. Let's do the other one. Okay, so let's do this side now.
I feel like I just missed it, but how did you get the 12? You can't.
Sorry. It's 3.
Okay.
I'm thinking about something else, that's why. I'm not thinking about the number. The number piece is easy. I'm just worried about something else. Okay, so that's me pulling out vertically. Okay, that's what's common vertically. Now horizontally, you can read off the factors too. Okay, what's common in the first one? 2 doesn't go into 3. It can't. Numerically, there's nothing that's going to work there, right? But the x can come out, right? And then I'm looking at the bottom. I'm going, okay, well, what can come out there? The 12 again, right? Because 24 won't go into 36, but 12 will, right? Now I'm wondering what's going on up here between these two. Because these should match. It works 100% of the time, I promise. It's just so I've done something here, right? We can try another one. Right? Yeah, I'm just trying to.
Wouldn't it be minus because there's the -3 and the -24?
Anytime, yeah. Typically, you might think that, but then I found out like in order to factor out the negative had to be in both of them in order for it to come out like that. I might have to figure this one out. I'm gonna have to figure this one out. Why that came out to be positives. We'll try the next one. I'll come back to that later. Okay, so which way do you want to use? Again, I don't.
We can use either.
You can use either. Yeah, it should come out to be the same. I don't know why it's the negatives make things a little bit more difficult. But if we came down and did C both ways, let's just do C for a sec, so you trust me, because I didn't really do a good job of making you trust me there. Let's do. I need to multiply two things to multiply 2. 3 times 4 is 12. I need them to add to 13. Right? So what are those two things going to be? Yeah, Ian. 12 and 1, right? So 1 and 12. You're going to start right at the beginning with your list. You're going to confirm that it's 1 and 12, right? And then I'm going to have to break apart the middle term to use decomposition, right? I'm going to go, okay, well, 3x squared plus an x plus 12x plus 4. Okay. Then I'm going to go, okay, well, I'm going to break this down the middle. And I'm going to deal with what I can factor out in the first two and what I can deal with in the second two. Okay. Okay, so I see I can take x out of the first one, and I'm going to be left with 3x plus 1. And the second one, I can take 4 out, right? So 12 divided by 4, I'm going to take the 4 out first, and then I'm going to get 3x plus 1 again, right? And then I see the two 3x plus 1 sitting there. You can factor those out. So it's 3x plus 1, and then I write what's left after. X plus 4. So there's your answer. Okay, now if I were to do this with the table, you always, in order to use a table, you still have to get those two numbers, right? You still have to go through the man process in order to make this work, right? So I'm going to draw the table. And I'm going to fill it out. So I'm going to go 3x squared. I'm going to go 4 in the bottom right. And then I'm just going to insert the other two numbers, 1 and 12x. Okay, and I'm going to just read vertically. So I'm going to read vertically here. I'm going to go, okay, what's common between 3x squared and 12x? 3x can go into both. And then I can take I have 1 and 4. What's common between 1 and 4? Just 1, right? Positive 1. Okay. And then I can go, okay, well, let's go sideways here. 3x squared and 1x. I can take an x out, right? And then what's common between 12 and 4? So then your final answer is I'm just going to write these two beside each other, right? I'm going to go 3x plus 1 multiplied by x plus 4. The negatives make things a little bit trickier. Okay, everybody okay with that? I promise you it works. I made a mistake somewhere doing something in the table. Okay. Let's try this one up top. Two numbers to multiply to negative 24, add to negative 5. What are we going to do? I'd start my list. 1 and 24, not going to work. 2 and 12, not going to work. 3 and 8. 3 and 8 sounds nice, right? So 3 and 8 is going to give me 24, and then I got to make it negative. So which one am I going to make negative is the question. Yeah, so if I make the 8 negative, then 3 plus negative 8 is going to be negative 5, right? So then I check both my conditions. And if I would like to, I could use decomposition. Right? So let's go 2x squared plus 3x minus 8x minus 12, right? When I break the thing down the middle, factor out, so what's common between 2x squared and 3x? X. And then I'm going to be left with 2x plus 3, right? And I should expect to see in the second half, if I take out the negative 4, I should be left with 2x plus 3. So then I get my final answer is 2x plus 3 multiplied by x minus 4. Right? Because again, I see the commonality between these two, right? When I set this up. That's as far as you can go, right? You can't go any further. Unless, like, the only way you could go further is if there was like if this was a 4. Yeah. Then you could take the 2 out. Right? And you're kind of stuck. That's as far as you're going, I think. Now, for my own personal interest and for your interest, because I do really like the table, let's make sure the table can crack it. It should work every time. Right, so I'm going to write the 2x squared in the top left. I'm going to go negative 12 down here. And then I break the middle term up with a positive 3x and negative 8x. Right, so those are my factors. These are my numbers. When you're using the table, this is where your numbers go. Then you just read sideways. What comes out of 2x plus, or 2x and 3x, 2x squared and 3x? Just the x, right? So I was going sideways. And then with the negative 8, see how both these are negative, Hector? This is what I'm getting at. This is what didn't make sense to me in the other one.
Yeah.
See how both these are negative?
Yeah.
That lets me take it out because it's in both of them. That's what's confusing me about the other question.
In the other question, you wouldn't be able to take it out.
Yeah, the other one had one of them was negative, so you had to leave a positive. That's what I got to figure out. I don't know what's going on there. So this took me a bit to figure that out, right? Because this is a really good method. I didn't like it until I actually figured that out. I didn't know what to do with the negatives, right?
So why was it different than the other way we did on the top
I don't know. That's why I got to figure it out. Yeah. Right? Because that's going to give me the piece that I want, the x minus 4. And then if I read vertically, I can take the 2x out, right? I can't take out the negative from the negative 8 because it's not in both of them. So then I'm going to go, okay, well, it's 2x that I can take out vertically. And the same thing on the other one. I can only take out the positive 3 because there's not a negative in both. So it's 2x plus 3. Right? So there are your two factors. So that one works again, right? I just don't know what happened with the first one. I've done something little, I think. Nope. So if I multiply 2 times 4 or 4 times 2, I get the same answer, right? So multiplication is like, you can do whatever order you want, right? I think, what do they use? The word for that? Commutative or something like that?
So you can't take the negative out.
Unless it's in 2 of them. That's what's great about this question.
Yeah.
See how the negative is in both the negative 8x and the negative 12?
But for B, if you were doing B, you would be able to...
I don't know. I haven't done B. Let's do B. You want to do B? You want to use the table? I'll just check the table. Okay. So you can pick. This is the first method. That's the one we discussed today. This is the second one. You can pick either of them. In theory. Okay. I'm going to try and squeeze this in here. Okay. So I'm going to need 2 numbers that multiply to 40. Add to negative 22. What are those? Okay, good. Good. Okay, so that one's a little bit easy. You can kind of see that one, right? Like 1 and 40, you're like, not going to work. So I'm going to go to 2. 2 and 20. Okay, well, that works, right? I can make a combination work there. Right, so I'm going to go 2 times 20, and then you got to make the sign work so that it adds. So they both have to be negative, right? Negative 2 times negative 20 is going to be positive 40. If I add them together, I get negative 22. So that's good, right? And then I'll go over here. I'll do the table first and see what happens. We get answers that we like. Right. So 10c squared, 4, negative 2c, and negative 20c. Okay, and then I'm just going to start reading vertically. Do it in different colors. See it? So vertically, 10c squared and negative 20. I could take 10 out, 10c. Right? And then in the next one, there's not a negative in both, so I'm stuck just taking out a positive 2. Right? And then I can check horizontally. So horizontally, a 2c can come out, right? Because not both of them are negative. And then 4 goes into the 20. Again, they're not both negative, so it's got to be positive 5. So then my answer is going to be, this is what I like about this. It's just clean, right? It's like everything's in the table, and then you just write your answer. 10c plus 2 multiplied by 2c. Now, no, now that I'm thinking about this, we discussed a method to check if we were right or wrong, right?
Yeah.
So if we go to the top question, if we expanded our 2 answers, right, we would know which one's right and which one we would have to fix, right? We'll do that in a sec. Okay, so I'll just do the decomposition, and then I'll give you the sheet you guys to work on, and then if we get to it, we get to it. If not, if we want to keep doing, I think that's probably enough for today to get you guys going on the complex trinomials, and we'll do the other 2 tomorrow. Right? And then that wraps up the week, and then you guys got your test on Monday, right? And I said you guys can bring some review questions with you tomorrow if you want. We can do kind of a structure. And that goes for like anything that I've given you over the course of the semester you could bring with you tomorrow. Okay. So, I'm going to write 10c squared minus 2c minus 20.
Does it matter what order you put the 2c and 20?
No. The one thing I used to do is I used to, like, for instance, this is a perfect example. It doesn't matter. Sometimes I would prefer to match things up a little bit better.
Yeah.
Right? So I might choose to go, I might actually choose to change these visually. I might choose to go minus 20c minus 2c because I think the 2c goes better with the 4 and I think the 20c goes better with the 10. Right? You can choose to do whatever you want. I just visually like factoring out what's common. It looks a little bit nicer, right? So I could take the 10c out, right? So I'm breaking it down the middle. I'm going to get the 10c. I'm going to factor out. I'm going to get c minus 2.
Yeah, that's where my confusion.
That's interesting, isn't it?
I think if you do the second one, it
shouldn't matter though. Just keep going here for a sec. Isn't that interesting, eh? There's another one. You gotta figure these out.
so you find it's really
See, I already know the other one's not right. Because if I expand this, there you get 20c squared.
Huh.
Yeah, that'll be tomorrow. We'll probably do that tomorrow. Okay? So we just got to figure these out. That's all. Figure out why that's not going right when you start throwing the negatives in. Okay?
None of us are going to be here tomorrow.
Oh, that's right. Forgot about that. Yeah, you're at what are you doing tomorrow? That's right. That's right. Okay? So I'll figure this out. I'll give you the sheet. You guys can still choose. Like, it's not... Just be weary if you start seeing the negatives. Just be weary, okay? We'll figure out what's going on here, okay? So I'll give you...